Okay, let's do the key for all these practice problems here. Key. Here in this front page, we're using this function f of -2. We'll replace all the x's with a -2 in parentheses. So -2 in parentheses squared is 4 plus -2 times 10, 20 plus 21. Let's say it'd be 45. All right, that's 24 plus 21, 45. I like it. Y-intercept is a point. In fact, it's the point 0, 21 right there. Y-intercept. X-intercepts. Set the function equal to 0. Factor. It's -3, -7. We get x, that's a 3 right there. X equals 3 and 7, but intercepts are points, not numbers. So that's the point 3, 0, 7, 0. Vertex H, opposite of B over twice A. I'm going to try using a pen. That's coming through a little dark. So, opposite of B. B is -10. Opposite of that will be +10. Yeah, that's a little better. A is 1, so over 2 is a 5. K then is f of 5, which would be 25 minus 50 plus 21. So that's -25 plus 21, I think is -4, right? Yeah, looks right. Now we're sketching the graph. So our y-intercept is way up here at 21. 8, 9, 10, 11, 12, 13. There's the y-intercept. X-intercepts 3 and 7. 3, 4, 5, 6, 7. 3, 0, 7, 0. Vertex right in the middle there, down -4. This graph points up because A is positive, and we're done. All that needs to be included. Okay, next page. We're solving. Here it's the quadratic. We got to get everything on one side. If you're solving a quadratic, you have to get everything on one side equal to 0. This factors. If it didn't factor, we use quadratic formula or completing the square. So is that right? -3? Yeah. So we get x equals 3 and -1. We're just solving. We don't have to write those as points. We're not looking for x-intercepts. Here we can use the square root property because we have stuff squared equals a number. Take the square root of both sides. Don't forget the plus or minus right there. X plus 4 equals plus or minus 5. So x is -4 plus or minus 5. -4 plus 5 is 1. -4 minus 5 is -9. We check those. I always like to check these really quick just to make sure. 1 plus 4 is 5 squared is 25. -9 plus 4 is -5 squared is 25. Looks good. Okay, here, this kind of exponential, we can't possibly, or at least easily, write both sides using the same base. So we take the natural log of both sides. That brings the exponents down in parentheses. It's the whole point of taking logs. We distribute all our logs. I don't know if I left enough space on this one. We get everything with an x, these two, over on the left, everything else over on the right. I'm going to move over here. So x ln 2 minus x ln 5 will equal 4 ln 5 minus 3 ln 2. Factor out the common factor of x. and then divide. Okay, there's our final answer. Okay, here we're solving a log equation. This does not have logs everywhere. This guy is not a log. So my ultimate goal is to convert to exponential form. I combine my logs together. Added outside becomes multiplied inside. Convert to exponential form. 2 to the second power equals what's inside. Okay, that's a quadratic equation. We know how to solve quadratic equations. We simplify, get everything on one side. So we get 4 equals x squared minus 3x. That's a really ugly equals right there. Or x squared minus 3x minus 4 equals 0. Without factors, that's x minus 4, x plus 1 equals 0, so x equals 4 or negative 1. But we have to check our answers. You can't take a log of a negative or 0, so we have to make sure these answers are allowed. So if I use 4, I can take log of 4. 4 minus 3 is 1. I can take log of 1. That guy's good. Negative 1. I can't take log of negative 1. I'm done. That one's no good. There's only one good solution. Okay, this is a polynomial and it's already in factored form. The roots, the solutions are right in front of me. X equals 4, negative 7. Technically it's 4 5 times. I could write out 4 5 times, or I could write 4 multiplicity of 5, but that's not necessary. The question just says find the solutions. I found them. Okay, that's not going to factor. I can look at that and see it's not going to factor. So we're going to need quadratic formula. Okay, so that's x is opposite of b, plus or minus, square root of b squared minus 4 times a times c, all over twice a. Sorry, a is 1. So that's negative 4 plus or minus square root. Negative times a negative is a positive, so that's going to be 16 plus 24, which is 40, right? 16 plus 24, yeah. 40 over 2. We could just circle that. I would give you credit for that, but that does simplify. Square root of 40, little side work over here. Root 40 is root 4 times root 10, which is 2 root 10. So I could write this as negative 4 plus or minus 2 root 10 all over 2. And then I could even split that into 2 separate fractions and simplify each one and get negative 2 plus or minus root 10. It's negative 2. Show that negative shows up. Either one. Okay, we didn't do this semester, so this one was not necessary, but if you want to know the answer, equations of circles look like this. That's a y. It's k squared equals r squared, where that's h, and that's k, and that's r. So this would be x plus 4 squared plus y minus 7 squared equals 36. Okay, so here we got some graph transformations. This is going to be y equals x cubed, scooted over 2 to the right and up 4. So instead of passing like this, instead of looking like this right here, it's going to go here and here. Now you may be wondering, wait a minute, how do you know you got the y-intercept right? How do you know where the x-intercept is? It's a sketch. It's okay. The question doesn't say get every detail right. It's just a quick sketch. That's all I'm looking for there. That's perfect. Keep in mind that these graphs do not look like, I'm going to write this out here, not something that looks like this. These guys are, x cubed does not look like that. And not something that looks like this. Ew. Those are wrong. That's what x cubed looks like. Okay, now we're going to find the inverse. So the first thing we do is y equals, change the f of x to y. Swap x and y. X equals y minus 2 cubed plus 4. Move the 4 over. Take the cube root of both sides. Cube root of junk cubed is just junk. Move the 2 over. Y will be cube root of x minus 4 plus 2. And then rename, it was f, right? So f inverse will be cube root of x minus 4 plus 2. Now here's a quick check. First off, it should be obvious the inverse of a cube function is a cube root function. Here I've got a plus 4 outside and the inverse a minus 4 inside. Minus 2 inside, plus 2 outside. All the opposite stuff in the opposite order. And then the graph is going to look like x cubed, look like this, but scooted to the right 4 and up 2. So that will look like, no, that's an awful graph. That was a very poor drawing. I'm going to do that again. Okay, so we want our graph to go like this and like this. Yeah. I don't know what happened there. It kind of went the wrong way. That's the graph. Okay, now we got this rational function. We got to find everything. Domain, asymptotes, intercepts, all those 7 steps we had in the video. So domain, bottom's not allowed to be 0. X is not allowed to be 4. That's negative infinity to 4, union 4 to infinity. Vertical asymptote, same question. Anybody that makes the bottom 0 is an asymptote. Asymptotes are lines, not numbers. X equals 4. Horizontal asymptote. Degree of the top is 1. Degree of the bottom is 1. Ratio of leading coefficients. Y equals 3 over 1, which is just 3. Let's put that stuff on the graph. Here's my vertical asymptote, x equals 4. My horizontal asymptote, y equals 3. Let's find some intercepts. X-intercept, we get just by setting the top equal to 0. We get x equals 2, so 2, 0. So that's right there. There's my x-intercept. The y-intercept, we get by plugging in 0. G0 will be negative 6 over negative 4, which is 3 halves, 1.5 if you like. 0, 3 halves. That is right there. Okay, so this whole section here is done. I do technically need to check and see if I'm going to cross over the vertical or the horizontal asymptote. So let's do that here. Cross horizontal asymptote. I know I'm not going to, but let's check it. 3x minus 6 over x minus 4 equals 3. Set the function equal to the horizontal asymptote. Okay, so I cross multiply, 3x minus 6 equals 3. X minus 4, and I get 3x minus 6 equals 3x minus 12. I get negative 6 equals negative 12. No. So all of that right there is no, we don't cross. Okay, if we don't cross, this graph's not going to come up and right on top. Over here, I know the graph either has to then live in this section right here or right here. If it lived right here, there would be an x-intercept. There's no x-intercept there, so the graph must live there. Okay, that one's done. Okay, now we're graphing a polynomial. We have to go through all those steps. The degree. 1, forget about the -2, it's an x to the first, so 1, 2, 3, 4. The leading coefficient, number in front, -2. So my end behavior is both down. Even degree, so the arms go the same way, either both up or both down. Because the leading coefficient's negative, they're both down. Okay, my roots and the multiplicity of each root. I'm going to put these in numerical order. Smallest one's -3, multiplicity of 1, that's a pass. Then 0, multiplicity of 1, another pass. Then 4, the multiplicity of 2, that's a bounce. Okay, so -3, 0, 4. My end behavior was both down. I was pass, then bounce. Okay, I already have the y-intercept here because 0 was a root, so I should write that. Y-intercept is 0, 0. Other than that, we're done. Okay, difference quotient. These have to be written out a very particular way. If you want to do side work over here, that's fine, but label it as side work. I'm not going to do the side work because I've actually practiced these and I know what's going to happen. Write down this thing here. Put an equal sign and start writing what that's equal to. F of x plus h means replace all the x's with an x plus h. That's this part. That's f of x plus h. Minus f of x. I'm going to put that in parentheses. All over h. This is over h. This side better be over h too. So there's f of x minus, there's f of x plus h minus f of x all over h. Okay, if you've done even 1 or 2 of these, you know that that x plus h squared is going to become x squared plus 2xh plus h squared. And now just do all your distributing. Minus 3x minus 3h plus 5. Distribute that minus. Minus x squared plus 3x minus 5 all over h. Everything past this minus should cancel out. Boom, 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 cancels with that, and with that. Everything that's left should have an h in it. Factor out that common factor of h. Cancel the h and write down what's left over. That's what a good solution should look like. Exactly like that. Now, if you have to do some side work over here to maybe figure out this part, f of x plus h, that should be on the side. This is what your final solution is going to look like, your final write-up. Okay, to determine if functions are even or odd, we replace the x with the negative x, and we see what happens. Here, f of negative x would be absolute value of negative x. Absolute value kills negatives. That's the same thing as regular absolute value of x, but hey, that's the original function. That makes this guy an even function. Here, replace every instance of x with a negative x in parentheses. A negative cubed is still a negative. A negative times a negative is a positive. Hey, that's the opposite of the original function. Everything changed. It's a negative. That makes this an odd function. Okay, here, replace x with a negative x. 2 times negative x plus 4. I get a negative 2x plus 4. That's not equal to the original, because that positive 2 is now a negative 2. It's not the opposite of the original, because the 4 didn't change, so this guy's neither. And this one, replace the x with a negative x. Negative squared is a positive, so we get 3x squared plus 9, but that's the exact same thing I started with. That guy is an even function. Okay, now the shortcut here is if all your powers are odd, cubed is odd. X to the first, odd. If all your powers are odd, you got yourself an odd function. If all your powers are even, you got an even function. If you have a mixture, then it's neither. Like here, remember that 9, I don't care if the 9 is positive or negative, or even or odd. I care if the power of x is even or odd. That's an even power. That's 9 times x to the 0. There's no x there. That's also even. Everybody's even. Here, everybody's odd. Here I have a mixture. That's an odd power and an even power of x. Okay, here we're solving by completing the square. First we would divide by whatever number's here, but there's nothing there. Next, move the 21 over. I like to leave a little plus blank. Take half the middle number. So half of 4 is 2. Squared is 4. Add it to both sides. Left side's going to factor x, whatever that sign is, and then half of that number, squared. Over here, 21 plus 4 is 25. Take square root of both sides. Don't forget the plus or minus. Square root of junk squared is just junk. Square root of 25 is 5. So we get x is 2 plus or minus 5. We can actually solve that. If we had radicals, we would just leave it, but we can finish that. 2 plus 5 is 7. 2 minus 5 is negative 3. Okay, we want to solve this nonlinear inequality. So that guy factors, that's x minus 5, x plus 5. So we're going to have an x minus 1, an x minus 5, and an x plus 5. And up here in our number line, a negative 5, a 1, and a 5. Okay, this guy's going to change at 1. He's negative below, positive above. He changes at 5, negative below, positive above. He changes at negative 5, negative below, positive above. 3 negatives is a negative. 2 is a positive. 1's a negative. No negatives is a positive. What do I want? I want negative. So I want these two sections. What about endpoints? The 1 is good. I can use 1. Both of the 5s are in the bottom, though. They are open circles. So that would be negative infinity to negative 5, parentheses, union, 1 to 5. Okay, dealing with some logs. Log base 3 of 9 is 2, because 3 squared is 9. Log base 2 of 1/8 is negative 3. 2 to the negative 3 power is 1/8. Log of 1 is always 0. I don't care what the base is, because anything to the 0 power is 1. You can't take log of 0 or negatives. This one does not exist. Okay, we got Dave throwing stuff off a building again. Remember, this one's going to trip you up. You have to find when before you can find what. We're looking for the vertex. This is a projectile motion problem. We got Dave throwing this ball up in the air. We're looking for the vertex. So H is the opposite of B over twice A. So that would be negative 64 over twice negative 16, negative 32, that's 2. That's not 2 feet off the ground. That is not the maximum height. That is the time, 2 seconds. To find the maximum height, we plug that back in, that time back into the function. So that would be negative 16 times 4 plus 64 times 2 plus 192, which is 256, I believe. Let me pause and check that, but I'm pretty sure that's 256. Yeah, that's 256 feet. That's the maximum height. So the ball reaches the max after 2 seconds, and the height is 256 feet. It hits the ground when the height equals 0. So negative 16t squared plus 64t plus 192 equals 0. I can divide through by negative 16 here and make my life easier. And I'll get t squared minus 4t minus 12 equals 0. That factors t minus 6, t plus 2 equals 0, and I get 2 answers, negative 2 and 6. Negative time doesn't make any sense in the context of this problem. Dave's standing up on the building at that point. He hasn't thrown the ball yet. So the only answer that makes sense is 6 seconds. The ball hits the ground after 6 seconds. Okay, now the additional problems. Okay, we're getting there. We're almost done. Find the doubling time. That's when we have double our initial amount. Right there is the initial amount. So when I have double that, I'll have twice that. Hey, look, the p-naughts cancel out. And I'm just solving this equation. 2 equals e to the 0.03t. I take the natural log of both sides. Natural log of e to the anything, those are inverses of each other. They just cancel out. So I get this equation, just divide, and I get t equals ln of 2 divided by 0.03, and that's in hours. I guess I'll throw that in a calculator for you. You can just type that in a calculator. And I got 22.36 hours, approximately. Exact form is fine. You could have left it like that. Okay, so now we're given an initial amount. That's the p-naught. We want to know when we hit 16,000, so 16,000 will equal 3,000 e to the 0.031t. So divide over the 3,000. I'm going to do a bunch of canceling there. So 16 over 3, which is, what, 5.33 approximately, equals e to the 0.031t. Take the natural log of both sides. Natural log and e cancel out. I get 0.031t equals natural log of 5.33. Divide. Let me throw that in a calculator. And I got about 54 hours. Which makes sense in the context of this doubling time. Every 22 hours, roughly, we double. So we start with 3. After 22 hours, we'll have 6. After another 22 hours, we double that. We'll have 12. So after 44, roughly 45 hours, we'll have 12,000. A few more hours, we're up to 16. Okay, we want to find the exponential model that passes through these points. We write down f and f. We make a fraction out of our y values 2 different ways. I always like to put the bigger x on top. I'm using these two x's, 4 and 2. Okay, according to the points, f of 4 is 324, and f of 2 is 36. But according to the formula, f of 4 should be a b to the 4th. That's just an x value. And f of 2 should be ab squared. Those a's cancel. I can reduce these b's. B to the 4th over b squared is just b squared. So I get b squared equals whatever this number is. Well, that number is just 9. Take the square root, b is 3. I'm halfway done. I needed to find b and I need to find a. I'm halfway done. I've got b. Now to find a, I plug either point back in. I'm going to use the one with smaller numbers. So I'm going to use 236. 36 is supposed to be a, whatever that is, times b, which I just found, squared. So that's 36 equals a times 9. So a equals 4. That's an a, that's a 9. So then my model is f of x equals 4 times 3 to the x. Okay, this system of equations problem. Let A be adult tickets. Let B, or C, be child tickets. Okay, we then had 120 total. A plus B equals C. A plus C equals 120. We made $8 off the adults, so 8A plus 3 times C should be 560. Solve that system of equations. So A would be 120 minus C. Take that and plug that in there. 8 times 120 minus C plus 3C should be 560. What's 8 times 120? 960 maybe? Let me check that. Should have paused, but now you're listening to me type. 8 times 120 is 960, yes. So 960 minus 8C plus 3C equals 560. So that's negative 5C would be negative 400. Is that right? So then divide by negative 5, and we get C equals 80. So that's 80 child tickets. A is 120 minus that would be 40 adult tickets. So 40 adult, 80 child. And then I would, I trust my work here, but I think you should plug those back in. I guess we could do it really quickly. 80 times, or 8 times 40 would be $320 plus another 240. So 320 plus 240 is 560. It works. Okay. Okay, we want to find the inverse of this guy. We could use either natural log or log base 2. I'll do it both ways. So first, y equals 2 to the x minus 7. Swap. X equals 2 to the y minus 7. Move the 7 over. X plus 7 equals 2 to the y. So right here is where we're going to make a decision. So I'll do it two different ways. I'll use log base 2. Because that's the base I already have. Over here, log base 2 of 2 to the y, those cancel, we just get y, and we're done. That's why I think that's the cleaner way. F inverse then of x is log base 2 of x plus 7. You're done. Or maybe you got here and took natural log. These do not cancel. They're not the same base. Let me put here. Or. That's an or. That's a very ugly or. Or. So here the y just comes down. And then you have to divide by the ln of 2. And you would get f inverse equals ln of x plus 7 over ln of 2. Those are, in fact, the same. Either one is fine. Let's just change a base formula to get between them. Either one's fine. Okay, so now we're supposed to graph these. Okay, so this guy is an exponential function. 2 to the x is exponential growth. So it would normally look like this. Have an asymptote here at 0. But because of that minus 7, we're going to be shifted down 7. So there's 7. I get a horizontal asymptote, and it's going to go like this, go right there through negative 6. An exponential growth. Okay, this guy, log base 2, normally goes like this, goes through the point 0, 1, has an asymptote at 0, but it's been scooted backward 7. Now it'll have an asymptote here at negative 7, and it'll go through negative 6 and look like this. So here's f inverse. Okay, another difference quotient problem. I hope I left enough room for this one. So we write out what we're trying to find. F of x plus h minus f of x all over h equals. Okay, f of x plus h is 3. X plus h squared minus 6. X plus h minus 1. Minus everything original. All over h. So there's f of x plus h minus, that minus, f of x all over h. Okay, do some distributing here. X plus h squared, order of operations. I have to do that before I distribute in this 3. So that will be 3 x squared plus 2xh plus h squared. And go ahead and do all the other distributing. Minus 6x minus 6h minus 1 minus 3x squared plus 6x minus 1 all over h. Distributed the minus 2. Okay, this would be 3x squared plus 6xh plus 3h squared. And I got to recopy all this. Don't be lazy. All over, don't forget the over h. Okay, all 3 of those better cancel. Cancel, cancel. 6 things cancel. And I'm left with 6xh plus 3h squared minus 6h all over h. I got a common factor of h. I pull it out. 6x plus 3h minus 6 all over h. Cancel the h's, and I'm going to have to write it here. Preferably that would be written down below here. 6x plus 3h minus 6. Okay, that one's done. Average rate of change is g of 4 minus g of 2 over 4 minus 2. Change in the y values over change in x is just slope. Okay, so I need over here on the side g of 4. Oh, well, I'm going to need the calculator for this. Okay, so hold on. Let me pause you for a minute. Okay, so according to the calculator, g of 4 is 728, g of 2 is 32. So that's 728 minus 32 over 4 minus 2. So let's see, minus 28, so minus 4, 696 over 2, which would be 350 something. That's 348. That's our final answer. Next page. Whenever we're dividing, we have to make sure we fill in all our missing zeros. Oh, that's plus 1. X to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. Okay, x cubed times x is x to the 4th. X cubed plus x, or x to the 4th plus x cubed. Draw the line. Change the signs. I get a negative x cubed plus 0x squared. That's going to be a minus x squared. It's a negative x cubed minus x squared. Draw the line, change the signs. It's x squared plus 0x. It's just a 1 again, so plus x. X squared plus x. Draw the line, change the signs. Minus x minus 1, minus 1, minus x minus 1. Draw the line, change the signs. Remainder of 0. So x cubed minus x squared plus x minus 1. Okay, here. X minus 2 for x cubed plus 6x squared minus x, 8x plus 2. No missing powers of x. I don't have to put any zeros in. To get from x to 4x cubed, that would be 4x squared. Distribute. 4x cubed minus 8x squared. Draw the line, change the signs. I get 14x squared minus 8x. So plus 14. That would be 14x squared minus 28x. Wow, these numbers are getting big. Draw the line, change the signs. 28 minus 8 would be 20x plus 2. So that would be plus 20. 20x minus 40. Draw the line, change the signs. Let's cancel. I get a remainder of 42. So here, plus 42 over x minus 2. Okay, next page. We want to solve this system of linear inequalities by graphing. Okay, so first I'm going to graph y equals 2x minus 1. Has a y-intercept at negative 1. Slope of 2, so over 1 up 2. I want a solid line because it's equal to. And then I'm shading underneath it. Here, y-intercept is 0, 4. Slope of negative 3, if I go over 1 down 3, it happens to hit the same point. This one's a dashed line because of no equal to, and I'm shading above this one. So, right there. There's my solution, that shaded region. Okay, we're graphing this piecewise defined function. This guy, x squared plus 3, is y equals x squared. Looks like this, but I only want it negative 2 and below. So if I were to plug in a negative 2, I would get 4 plus 3, I would get 7. So I'm up here at 7, open circle. That's this piece right here. Here, that's a line. In fact, that's that line I just graphed right there. That's a coincidence. I didn't do that on purpose, but it is. That's this line. Right here, goes through the points 0, negative 1, and 1, 1. But I only want the line from negative 2 to 1. So from here to here. I only want this section of it. And I should label what these y values are. So at negative 2, that would be negative 4 minus 1, that's negative 5. And that's a solid dot right underneath that open circle. At 1, I already found that. 2 minus 1, I get 1. That's an open circle because no equal to right there. And then this guy here, square root of x plus 7 minus 1 is root x scooted 7, so it's 4, 5, 6, 7, and then down 1. That guy kind of looks like this. But I only want this chunk of it from 2 on. So I'm going to start right here and go on. I have a little missing section here, and that's okay. Okay, so let's see what that y value would be. If I plug in a 2, square root of 9 is 3 minus 1 is 2. So I should only be up at 2. I kind of missed there with my dotted. Should have been more, I guess, like this. Okay, so then that's going to be something that looks, it's kind of crappy looking. That's going up and increasing. And that is an open circle. Okay, so let's highlight that. This is the actual graph. If I had done this in pencil, all those other little pieces would be erased. Those were just guides to help my graph. Okay, next page. We're solving this nonlinear inequality. So we list all of our factors. Minus 4, x plus 2, x minus 6, x plus 5. That 3 doesn't do anything. Here in our number line, put all of our zeros. So there's a negative 2, a negative 5, almost forgot him, a 4, and a 6. I didn't space that out very well, did I? It's okay. Okay, this guy's going to switch at 4. He's negative below, positive above. He switches at negative 2, switches right here, negative below, positive above. This guy switches all the way at 6, negative below, positive above. This one switches at negative 5, negative and then positive. Okay, that's 4 negatives. That's a positive. 3 negatives is negative. 2 negatives is positive. 1 negative is negative. All positives is positive. We want positive, so there, and there, equal to, so I want solid dots on all of these. So that was, well, not there. It goes on forever. Negative infinity to negative 5. Negative 4, or negative 2 to 4. And then 6 to infinity. So there's our answer. Okay. Same game here. List out all our factors. Draw a number line with all our roots. So I've got a negative 4, a 1, a 5, and a 7. Okay, this guy switches at 1. He's negative below, positive above. Switches at 4, negative 4, negative and then positive. Switches at 5 over here. Negative below, positive above. Switches at 7. Negative below, positive above. 4 negatives is positive. 3 is negative. 2 is positive. 1 is negative. None is positive. We want negative. I want here and here. Okay, I'm not allowed to use the 5 or the 7. They have to be open circles. I am allowed to use the 1 and negative 4, they are close dots. So that is negative 4 to 1, union 5 to 7. Okay, oh right, last page. We're almost done. Okay, vertical asymptotes, I only care about the bottom. That's x equals 4, x equals 3. X equals, don't forget that. Two of them here. That's negative 4 and 4. Set that equal to 0, you get x equals 5. Here we're going to do a little work, factor out that 5. X squared minus 4, that's 2 and negative 2. X equals 2, x equals negative 2. Horizontal asymptotes, we look at degrees of top and bottom. This is second degree on the bottom, first degree on the top. The bottom wins, that's y equals 0. Here, degree of the top and bottom are the same. We take the ratio of leading coefficients. 1 over 1 is 1. Here, the top wins, that's none. No horizontal asymptote. Here, degree of the top and bottom are both 2, so it's y equals ratio of leading coefficients, 3 over 5. Okay, in our last problem, I need to write 12 in terms of 2's and 3's. Well, that's 4 times 3, so that's ln of 4 plus ln of 3. But 4 is 2 squared. I can bring that 2 down and get 2 ln of 2 plus ln of 3. But ln of 2 we called u, ln of 3 we called v. That's 2u plus v. I get my u's and v's right? Yeah. Okay, divided inside becomes subtracted outside. 27 is 3 cubed. 4 is 2 squared. So that's 3 ln of 3 minus 2 ln of 2. That's 3, that's v, minus 2u. Okay, ln of 8, that's ln of 2 cubed. That's 3 ln of 2, or 3u. And ln of 6, that's 2 times 3, which is ln of 2 plus ln of 3, which is u plus v. Okay, that is it. That's all of them. Finally.